Hello everyone, today I am here to present my final year project, which is Deep Learning for Automated Chest X-ray Analysis, a diagnostic revolution. So these are my group members and our supervisor Dr. Faisal Rahman. Now come toward the first slide, that is introduction. This project focuses on creating an automated system that uses the convolutional neural network to analyze the X-ray images. The goal is to help doctors and healthcare professionals get fast and accurate results. The system is designed to detect the diseases such as the pneumonia, tuberculosis, COVID-19 using the well-known dataset like NIH, chest X-ray and Chexpert. So the problem statement: manual analysis of X-ray images takes a lot of time, requires skilled professionals, and can also lead to mistake, especially in the high or busy pressure situations. Without consistent and reliable diagnostic tool, there is a risk of delay in the treatment, which can basically affect the patient care. So the proposed solution is that the system provide the convolutional neural network with transfer learning by applying the powerful pre-trained model like the exception model. A user-friendly web-based application will be developed, allowing the professional to easily upload the X-ray image for the quick analysis. Then the system will generate the diagnostic report, and which can include the confidence score and the visual heat map. Basically, visual heat map highlight the important areas in the X-ray image. Now move toward the benchmark. This is the benchmark of our project. The benchmark, if we see in the in our system or the traditional system, our system is a real-time analysis. So some of these can hit the proposed system, some can hit the traditional analysis, and some can hit the existing automated system. So all of these are the benchmark of our project. Now come toward the objective and goals. The main goal of this project is to develop a web-based system that can automatically diagnose the diseases from the X-ray image. So by using the deep learning models, the system aims to deliver accurate, reliable and efficient results. It will also provide the visual indicator like the heat maps to help the healthcare professionals. So the the project offer real-time analysis for the X-ray image, and it can include the visual indicators such as the heat map, and each diagnosis is also supported by the confidence score. And the web-based application should also be used to clean and user-friendly interface, making it easy to upload the image. So the come toward the system flow diagram. Firstly, a data set of chest X-ray image should be imported, and it should be cleaned and collected through the data pre-processing stage. Then the clean data is used to train the model, and DL model to recognize the pattern and make the prediction. So the doctor can upload a new X-ray image and to a web-based application. Then the trained model analyze the scan image, and new scan image should be generated to predict the results. And a detailed report of the prediction should be provided by the doctors to analyze the report. So stakeholders. The key stakeholders in this project include the healthcare professional, such as the doctors and the radiologist. Radiology department in hospital and diagnostic center will also benefit from a faster and more reliable results. Patients are directly stakeholders, and they will receive the quicker and more accurate diagnostic results. Now the functional requirements. The system also allow users to upload the chest X-ray image for the automated analysis, and it will uses the deep learning model to detect the diseases like COVID-19, pneumonia and tuberculosis. And after analyzing the image, the system will generate a diagnostic detailed report of the system. Non-functional requirement. The system should deliver the high accuracy and fast performance, which can ensure the real-time diagnostic result. It must have a user-friendly interface that is easy to navigate, and the system must handle the sensitive medical data securely by following the privacy regulations. So the constraint of our project, that is data quality, computational resources, and the model generalization. The project faces a few constraints. One major challenge is obtaining the high quality and properly labeled X-ray image dataset. Another limitation is to need for the powerful hardware such as the GPU enabled systems, and which can provide the real-time prediction. And the model must able to generate well across through different patients type and medical requirements. So the functional classification, these are very important for the project. The system include the core functions such as the detecting the disease from the X-ray image, and allowing the user to upload images, and generating the detailed diagnostic report with the heat map basically. And non-functional feature focus on ensuring the smoother experience, and experience by offering a secure environment. So come toward the traceability basically ensure that all system requirements are clearly connected to the project's main goal, and it helps track the development of features throughout the design and implementation stages. And this process also makes sure that every requirement is properly tested and meet the stakeholders need. Design methodology: to improve the accuracy of disease detection from the X-ray images, a pre-trained deep learning model such as the exception model should be used, and these models are effective in extracting important features from the medical images. And then the trained model is integrated into a web-based application using the verb frame like the Flask and the Django's. Flask basically easy to use, and it is good for the small web-based application, and Django's are bigger and has built-in features which is good for the large web-based applications. Now come toward the use case diagram, and this use case diagram outline basically the key steps a user takes in building using the deep learning model for the COVID-19 detection from the X-ray image. The process begin with collecting the relevant data from the X-ray image, which are then prepared and organized for training. Once the model is ready, it is trained using the prepared data, and after training the model is validated and improve and it help to improve the accuracy of the models. Then the refined model is tested on a new X-ray image, and after that finally the user will analyze the predicted result, and which can evaluate the model's effectiveness and COVID-19 from the input image. Now the block diagram of our model. This block diagram represents the deep learning system for detecting disease like the COVID-19, pneumonia, and tuberculosis using the text X-ray image. The process begins with pre-processing, where the X-ray image is cleaned and resized. Next, the image goes through the image processing and augmentation stages to enhance the quality of the image. So these images are prepared then passed to the deep learning models built on the exception architecture with custom layer. Finally, the classification model identifies the label disease such as the COVID-19, pneumonia, and the tuberculosis. So the data flow diagram, this data flow diagram shows the step-by-step process to detect the disease. First, the X-ray image is cropped to focus on the important areas. Then in the pre-processing stages, two types of feature should be extracted. One should be enhance and resize the image, and other should sharpen the image. And these features are then set for prepared data set. And in the classification stage, the data set should be divided into two phases, that is the training and the testing phase. Then CNN model is trained using the training subsets with hyperparameter tuning to basically improve the accuracy. Finally, the trained model will give the results to identify which type of disease should be detected. So the Gantt chart, this Gantt chart shows the full timeline of our project. Phase 1 was completed between November to December and focuses on the data collection and pre-processing. Phase 2 from December to February involved the developing and training the deep learning models. In phase 3 followed from the Feb to March, and where we evaluate the model optimization. In phase 4, during March to May, we worked on the web application development. In phase, where we performed the testing and validation. And in from June to July, we will deploy the project and give the final presentation. Now move toward the backend. In Python, we will use the machine learning and deep learning. Firstly, we will import the libraries. We load a data set which can collect it through the different places and from the Kaggle accounts. For example, this is the data set. Basically, we have two folders which can be divided into testing and training phase. Testing, we have 16,000 plus images and have the 8 GB data. Testing should also be divided into four classes, that is the COVID-19 and normal class and pneumonia class and the tuberculosis. And also we can see that training should also be divided into four categories, that is the COVID-19, normal, pneumonia and tuberculosis. Now come toward the code again. After loading the data visualization, in which we divide the classes into basically the ratio form. So this is the ratio, and then we will do the data pre-processing, in which image generate data class is used, in which batch size of image is 32 and the image size is 299. So the model, so these are the classes, that is pneumonia class, COVID-19 and the tuberculosis. So model building, firstly exception model should be imported. After that, base model should also be imported, and we use the flattened layer, dropout function, and dense layer should also be imported. After building the model, we will do the model training, and we use the early stopping function, and basically patient size is mentioned, and which is 5, and we run the 20 epochs. So these are the epochs, and after that we will do the model evaluation. Basically we achieve the best validation accuracy, that is 97%, and which is highly accurate. And now the classification report, and which is 99% precision should be achieved. And after that, this is the confusion matrix, and this is the model training and validation. Orange line show the validation accuracy, and blue line show the training accuracy of the model. So this is the model accuracy. So now come toward the front end of our project. So move toward the front end. So basically this is the front end of our project. With the help of Flask and CSS, HTML, by using all these we created our front page. In the left side there is different pages also. So when we click on the run button, here is the run button. When we click on it, a local link should be generated. Let's see. So basically this is the link. When we press click and control, our home page will be appear. So this is the home page of our project, and when we move toward the detector page, we will just upload the sample image. First we will drop and drag or click the image. So this is the folder, and we will just select a sample image. Let's see COVID-19. We select this one, open, and we will analyze the image. After that it will generate the report. This is the COVID-19, and that is 99.91% confidence score, and this is the original pic, and this is the heat map generated by the model, and this is the affected part in which there is a COVID, and this is 99.91%. We will upload one more image. We will select from another folder from the training. Normal, we will select this one, open and analyze. Then the result, normal, that is 99.91% confidence score, and this is the original picture, and this is the heat map generalization, where this area should be affected by the disease, and heat map should be generated. So this is basically the detector function. So come toward more function. This is the detector page, about project, in which project workflow, data collection, model training, evaluation and tuning, web development, and data sets, in which training data distribution and the testing data distribution should be used, and these are the classes. If we move toward the modeled cells, there is test accuracy should be 98.81%, test precision should be 98.83%, test recall 98.78%, and validation accuracy we achieved 97.78%. So this is the visual analysis. Model accuracy comparison, where the training should be 99%, validation should be 97%, and testing 98%. And these are the training and validation accuracy confidence metric. So I hope you liked the video. Thank you so much.